Good morning, everybody. Hope you all are doing well. Wednesday morning, right? Everybody's brain's pretty well chock full of stuff at this point. Awesome. Well, good morning. I'm Quentin Van Diemen. I'm the Business Development Manager for AWS's Identity Services these days. For those of you that I might have met before, you probably know that Business Development Manager is probably not a very descriptive title for who I am. I've essentially spent the last 5.5 years running around the world helping a lot of AWS's largest customers work through some pretty complex identity and access management strategies, and that's kind of what's brought me here to you today to talk about access management in 4D. So I've had the distinct pleasure of being up on the reInvent stage actually 5 years now, and every year I try to frame these identity talks to sort of a fun backdrop, maybe even something a little cheeky. This year I went with this 4D thing, right? And it is my attempt at a triple entendre. Actually, in researching that, I figured out that triple entendre was more of a rap thing these days. I am definitely not a rapper, right? But I'm going to try to layer in 3 different meanings to that title. The first is that if you're familiar with IAM, and hopefully you all are, right? We always talk about the PARC model: principle, action, resource, and condition. And so the principle being the first dimension, action being the second, resource being the third, and condition being the fourth dimension of the PARC model. So if your geometry is a little rusty, which mine certainly was, that last shape is a tesseract, or at least as my colleague Greg has informed me, right? That is kind of an interesting object. It's one of those geometrical shapes where every plane is also a cube, kind of a mind bender kind of thing. There will not be a quiz on that later, but what we're going to really do is we're going to use this fourth dimension of the PARC model to really impart a lot of granular conditions into our access management. And we're going to essentially codify what we know to be true to further improve the principle of least privilege. So that's definition number 1. So the next one is the fourth dimension in physics, or at least one of them, is often time, right? And again, no mind benders on space-time fabric or anything like that. But we're going to look at some great patterns today to add the dimension of time to access management, and essentially go from always-on types of permissions that they themselves might be very good least privilege, but they're always on, and we're going to move that to just in time. And I think there's some really powerful things we can create there. And then my last meaning, and you can probably ding me that this one doesn't really fit the triple entendre thing, right? But this is very much going to be a level 400, right? We're not going to go through a lot of beginner terrain. We're really going to do some fairly advanced stuff. There's going to be extensive policy examples, lots of demo code and other things. Now, I have very deliberately embedded most of the core policies you're going to see today in the slides. So when you see them on SlideShare, they'll be there for you. I also tried to embed a lot of QR codes and other things for like the links that'll take you forward from those various points. You'll have all the slides, take pictures if you want, but know that all the things you're going to see kind of in the demos have been intentionally kind of included in the deck. And as I always do, I'll stick around the hallway for essentially as long as anybody wants or until they kick us out to do Q&A afterwards. Okay, so let's just quickly do a little bit of departure point, right, to kind of ground everybody in some topics that I think are going to be fairly key from where we go from here. So this talk is something of a continuation from the talk I did last year. Now, it's not like a Star Wars thing. You don't have to have seen last year's show to get some good insights this year. But if you find this talk today interesting, that's going to be a very deep dive in some particular pockets. Last year's talk was kind of the full spectrum, right? We took a walk soup to nuts across the identity landscape in AWS in the same sort of 400 fashion, and it might be of interest after the fact. Okay, so last year my analogy was this layer cake, right? And I presented the notion that when you're looking at identity and access management in AWS, there's essentially 3 layers of the cake that you need to consider. The bottom layer is about getting builders into the platform, getting them into the management console, into the CLI, into the API. From there, those builders generally create infrastructure, right? Not everything is perfectly serverless today, although we might all love it to be. And so they're creating operating systems, databases, things of that nature, things that exist in a VPC that have their own notion of identity. And we've got to sort out identity and access management for those components as well. And then the third and top layer of the cake was all about the applications, right? On top of that infrastructure, we build and deploy apps to which we have to have end users authenticate. And across all those layers of the cake, we're looking at both builders, the operators, and the end users, right? So that's the mental model I'll give you for the totality of the scope that we're looking at. Now, last year's punchline was that these lines were blurring fast, right? I ended with this icebox mocha cake where there was kind of a tiramisu-ish kind of thing where all the layers blurred together, and that's really where we're going to pick up here today, especially those bottom two layers of the cake. The line between them is essentially, if not totally eroded, it's going away super fast. Okay, so I mentioned that we're going to be focusing a lot on conditions, and assuming you haven't, broken out this page in the documentation in the last handful of days, let's do just a quick refresher because it'll be important for our discussion here today. When you put together a request into AWS, AWS gathers all sorts of information about that request. Who the principal was, where they called from, what they were calling, and we dump all that information into what's known as the request context. And then you, the policy author, essentially can use all of that information and write conditions against those elements in the request context using the condition block of the Park model, right? And if you specify multiple conditions or multiple keys against a condition, all of those get evaluated as a logical and. And if you specify multiple values against any given condition, those get evaluated as a logical or. But at the end of the day, the entire condition block must fully evaluate to true for the statement to hold. Okay, so now there are tons of condition keys, condition operators, right? Some are global, some are service specific. They're all in the documentation. We're going to look at a bunch of them today. It would not be a valuable use of our precious time here today to kind of go through them in very mechanical fashion. But here are the links to the docs where you're going to find all of those options that are available to you. Okay, and then last point of departure, we're going to talk about a bunch of different policy types today, right? And I want you to get in the mindset of thinking about the various policies across AWS as grants and guardrails. So a grant is a policy that actually gives permission, right? And notably, we've got resource-based policies and identity-based policies, the ones that you attach to roles or perhaps users in your environment. And those actually grant access. On the other hand, we've got a whole host of policy types that are guardrails, service control policies, endpoint policies, permission boundaries. And essentially, all of those do not grant any privilege. They narrow down the maximum permission or the maximum privilege that is possible, right? And they work through kind of intersecting logic that I hope most of you are familiar with. But the punchline here is that you can have any number of guardrails, and we're going to look fairly extensively at how guardrails intersect with grants, but you must have a grant for the action to go through. A guardrail itself cannot actually grant any permission. Okay, so now let's get started with the fun stuff, the meaty stuff. Part one today, we're going to do entirely out of the box, right? These are all things, these are all features that you can pick up and use and start with today. No building required. And the first theme we're going to look at is how you can achieve better least privilege through the intersection of multiple policies. And let's do that with an example to start, right? So here's my scenario, fairly simplistic one, but probably one that many of you can relate to. I've got an application running up in AWS. It's running on a host of EC2 instances that have got roles plumbed up underneath of them, and I want to access a bucket with some encrypted objects, right? Well, the first, obviously we've got to get started with a grant, right? And we give that piece of compute, essentially an identity, and we say that it is allowed to talk or to query in and pull and put or get and put objects out of that bucket, right? So a reasonable policy for doing something like that might look something like this, right? I've done a reasonable job of least privilege. I've got a good set of scoped actions there. I've very clearly articulated my exact key and my exact bucket, right? So it's not a bad job. It's a pretty good least privilege policy, even if a fairly simplistic example. But there's a lot more that I know about this environment, this application, particularly if it's a very sensitive application. For starters, I probably know exactly what VPC this thing runs in. As a matter of fact, I probably built a VPC just for it, again, if it's a critical application. And when I've done that, or when I do that, I can attach a VPC endpoint to that VPC And all of a sudden, I have another part of that context that's coming into AWS where I really can know and rationalize about the call origin, right? And so I can, again, use this power of intersecting policies. I can put a policy on the bucket that now says, well, hey, we already gave, you were already allowed to call and get and put those objects, but now I can layer in a restriction that says only when they come from this place that I expect it to come from. And so a policy, you could do this. I did it here as a deny because I'd already given the grant to the role. But this is a very simple example that basically it uses that condition. It uses the condition key about the source VPC, the source VPC endpoint, to say block any access, regardless of who's calling, to this bucket unless it comes from the place I expect. It's a very simple to rationalize thing, right? Okay, and so as a little tip, right, if you apply a policy of that nature to the bucket, you're not going to be able to even modify the bucket policy from the console. And I'll let you guess how I figured that out as I was putting together the demo, right? So just wanted to save you from that heartache. Cool. So, but we still know more, right? So notably, we now have a place on the network perimeter where we can further rationalize about things, right? We can say, from this VPC that I created for this very specific application, I know exactly what buckets I want to be accessing, and I know the exact people that should be accessing them. So we might put a VPC endpoint policy on it that looks something like this. And again, I chose an allow. You could do it with a deny. It's kind of 6 in one, half dozen in the other. But here I'm doing two basic things. I'm again giving I'm giving further restriction that says the only bucket that I'm allowed to connect to from this VPC is the one that I expect. And I'm also saying that the only principals that are allowed to make any S3 calls out of this VPC are the ones in a particular sliver of my organization. Now, if that principal org path context key that I'm using there looks new to you, it's because it is. It was just released, I think, November 20th, maybe. I might be off by a day or two, but it was just a couple. It's very new, right? And it's a very powerful way of saying not just one of my principles, but now one of my principles in a very specific part of my organization, right? So, yeah. And again, further kind of note, again, kind of same asterisks as before. If you apply this one, you're going to have to lift this policy before you can even modify the bucket policy from the VPC. Again, I'll let you figure out how I figured that one out. Cool. And then in the spirit of belts and suspenders, right, because you can never have too much defense in depth, we can even now that we have this VPC endpoint, we can come back and we can even add that sort of condition to the identity-based policy, right? That now says this credential is only useful when used in that VPC, right? And then the final thing we can layer in is we can even put a policy on the key, right? We can put a policy on the key. And key policies are rather unique in that they don't trust anything else. If the key policy says no, it doesn't matter what else says yes. And that's kind of a special, unique property. But when you put all of these things together and you look at where we started, which was, again, simple but a fairly reasonable least privilege policy, we've come a long way, right? Like if you think about what's in and what's been boxed out, by using these intersecting policies, we've really scoped things down a lot. And so that's kind of my takeaway. Now, I always try to be balanced in this, right? There is a flip side to doing these sorts of policy intersections, in that it's more taxing for the humans. It's not perfect, right? Like if you put all that together, there would be, sometimes where intermediate AWS services would have trouble with some of those policies. It's not necessarily a pattern to use everywhere, but for those critical workloads, for those real crown jewels, like this is an amazing way to scope down and really make sure that you're driving towards least privilege. So leverage it for those critical workloads to start. Okay, so next I want to talk about how to achieve the principle of least privilege through dynamically adjusting policies. Right? And so let's take a look at, so AWS to this point in history has mostly been about role-based access control, right? I have a set of users, I give them a set of policies, and in those policies I can get very granular and very specific about the resources that those folks can operate on. Now, the problem is as I add things, I have to update the policies, right? If I'm really trying to do least privilege, I have to continue, and I'm in this continuous cycle where every time I add resources, I got to update the policy, and it just becomes, I get stuck in this do loop where I'm continuously chasing after things, right? And the game goes on and on. Where we're going, right? And this is something that, again, you're going to see some great examples of this today. I think we'll see this become the norm in the future. We're really moving towards a world of attribute-based access control, right? And there, the policy now can be dynamic. It just allows us to write simple rules in these policies that say if the tag on the principal, on the user or the role, matches the tag on the resource, allow access, otherwise deny, right? And those are very clean rules, or simple rules to think about as the human, and they dynamically adjust to the environment around them. As new instances or buckets or whatever come in, as long as they're tagged appropriately, the access is automatically granted without needing to touch the policy. So it becomes very dynamic. All right, so let's look at our first demo of the day, right? So I built a little sample application that's going to help me kind of show some of these examples. It's not going to be terribly important for the first one, but it's going to be integrated in as we go through the talk today with a SAML identity provider that I've kind of wired into the app using Amazon Cognito. But what's going to be important for this first demo is I've given an identity to this underlying application, and I'm going to use attribute-based access control to do two things. One is I'm going to go in and make sure that it can only retrieve its particular secrets out of Secrets Manager. And then secondly, we're going to look at service-to-service authentication, right, or authorization, where we're going to look at how we can do attribute-based access control for one service calling a set of APIs. All right, so let's dive in. Machine went to sleep as usual. All right. So as we go through the demo today, I actually like this room configuration because it's not as deep. I've tried to bump up all the font sizes enough so that everybody can see. But if I'm looking down and I miss something that's too small, just shout out and I'll make it bigger. But as I go through today, I'm going to be kind of looking at two different personas. If you see me operating in Chrome, that's kind of the administrative view. That's where we'll look at a lot of the policies. And when I'm operating in Firefox, that's going to be kind of the end user mode, right? Okay. So first, let's go in, and we're going to look at just kind of the end result first. So I'm going to go to my little user portal. Now, before I go any further, I'll say that making demos of things that succeed or fail interesting is a challenge. Bear with me. I've tried to make it as compelling as I can, but there's only so much suspense you can hold when the thing is going to fail or the thing is not going to fail as you expect. So we'll try to make it as best we can. All right, so the first is let's look at, so some attribute-based access control for AWS services. Here, I've got, again, this is what you're seeing here is two basic calls. They're both going to Secrets Manager. One essentially was trying to retrieve a secret value where the tag on the underlying role matched the tag on the secret, and the other one was obviously not, right? So let's dig in and let's look at the policy that made that possible. So we'll switch over to my administration view here. I'll drop into the right AWS console. And first we're going to go and we're going to inspect the tags on the principal itself. So we'll go into IAM. We'll go into the role. And we're going to search for the front-end role that's underneath the hood of that thing. And we're going to look at, so you can see I've statically tagged the role here with a couple of tags, right? I just use project, team, department, and you can see team A, project 3, right? And so now let's look at the permissions that are on there, right? And so here's my policy, right? That's letting me go in and access Secrets Manager. And again, pretty well scoped thing. I'm just getting secret value. And here you can see one of those policies that I talked about. If the tag on the principal, right? If the project tag from the role matches the project tag on the secret, I'm going to allow access. Otherwise, I'm going to deny. And here I've used four conditions against the same key, so all four of those things have to be true, right? Now you contrast that with last year at this time. I did, again, kind of a different Secrets Manager type example. And this was the sort of least privilege policy I was doing last year, right? Where, again, this is well scoped. It is using kind of a naming convention to get very specific about the resources, but I'm only able to do essentially one dimension here, right? It's good least privilege, but if anything beyond like my naming convention, I can't do anything interesting on the authorization. So now, so let's flip over, and now we'll look at the secret side of things, right? And so I always use these little shell scripts that help me out because I can't talk and type at the same time. But if we look at the tags on secret 1, I told you I couldn't talk and type. I appreciate that it's maybe a little bit hard to see some of this scrolling as in the smaller screen, right? But all I did was describe the secret, my ABAC secret 1, and I can see that's obviously, as you'd expect, Team A, Project 3. And then if I do the same thing for secret 2, the one that failed, as again, no grand drama here, but we can just see that in this case, the project and the department tag matched, the team one didn't, and so that's what led to the end result of being denied, right? Okay, so ABAC for ABAC for AWS services. So now let's look at a second thing while we're here, right? So now let's go in, and now let's look at ABAC for your own services, right? And what I mean by that, and that's definitely too small to read, this is not a terribly, like what I did here is this application calling an API, right? Simple API that I wrote. In this case, it's just kind of echoing back who the caller was. It's not terribly important, right? So I've got one that succeeded and another one that failed, right? And so again, let's look at why that happened. So let's go in and we're going to look at the switched consoles one last time. Let's go in and look at the resource-based policies on these two APIs. So I'm going to go in here and go to API Gateway. So now again, I had that top microservice that I authored. I'm using a resource-based policy, right? And so this one is not really attribute-based access control, right? I am using this principal ARN context key to allow service 1 to call service 2, but I've essentially named it, I've named that principal. As a quick aside, this principal ARN context key is by far the best way. You noted that I did not use the principal restriction. It turns out to be much easier to think about how to do constraining by principal using this principal ARN because of the fact that the role isn't the person that's actually making the call. It's the role session, and the ARN for that is a little bit different. So use principal ARN if you want kind of a good, clean way to do those sorts of conditions. But that as an aside, let's go back and let's look at the other service, the service that didn't allow me to call, microservice 2, right? And here, you can see that I have used a attribute-based policy, right? Again, I'm saying the principal in this case must be in prod, and as you remember, like this role was tagged as project 3. Project 3 is not the same as project 2, and so I got that denied. I've also, very importantly, also specified, again, this principal org path, right? Like, there are a lot of people in AWS that can tag a lot of roles. If you're going to use a pattern like this, you need to make sure that your roles tagged as you'd expect. So I'm going to update the policy. I'm going to go ahead and deploy that change. And then this is the part of the demo that always makes me sweat a little bit just for fun, because I've got to take a couple of seconds to propagate that through. But if I hit refresh a couple times, there we go. So you can see now that it's gone through, and now what was a failure before is now a success. And while, on one hand, we're kind of highlighting attribute-based access control, I'd also take a moment to point out, like, this is something, like, doing service-to-service authentication and authorization in traditional ways, my little joke aside, involved mutual TLS, it involved network controls, it involved a whole bunch of stuff that was really complex, right? And here, I think this is one of those patterns where the cloud has just made something notably better. On one hand, the credentials were plumbed up under that role and automatically rotated by AWS through the metadata service. And on the other hand, I write a simple, easy to rationalize about policy and deploy that in one place, and AWS takes care of all the authentication and authorization for me. So really powerful pattern, I think. Okay, so let's flip that over. And let's look at another view of what we saw, right? So again, all of these policies are going to be in SlideShare. I went through them, but if you want to peek back, here they are. But the key takeaways here, right? No lists of resources or required naming conventions. The policy or the permissions all are dynamic. I could have put any number of secrets in there as long as they were tagged the right way. It automatically gets picked up. And just kind of a great example of how to do attribute-based access control for the principals. And then on the service-to-service side, right, so first we started with a type of policy that was very explicitly naming the principal on one side. And then we moved up and we improved that to be attribute-based access control for service-to-service. And again, I'll call it a second time just because I think it's really, really important to note that if you're not putting principal org ID or principal org path into a condition of the policy of this nature, right? Don't do it, right? Make sure you're constraining it in those ways. Okay, so now that was principal tagging, right? So I statically tagged principals. The next thing that we've this is, if you haven't heard of this before, it's again because it's very new. Late November, we released session tags, right? So session tags are essentially the same sort of concept. But now I'm backing up where the attributes come from on the person into an upstream identity provider. So this could be Active Directory, it could be Okta, it could be Azure AD, it could be OneLogin. It could be essentially wherever the source of truth for your users are. And again, I can draw in these attributes across that federation boundary and then use them to make access decisions in AWS. It's a really awesome new capability. And so when I showed you this picture before, I was actually taking a little bit of a simplification, right? The users themselves weren't tagged. The roles that they were assuming were the ones that were really tagged. So with session tags, that changes. The tags or the attributes move out to truly be on the users. And all of those roles that had to be tagged before all now melt away. And all of the users go into a single role. And essentially, the net is the principal tags made policies dynamic. The session tags make the roles dynamic. And the combination of those means that before you needed hundreds of roles, hundreds of policies to do all this least privilege. Now, again, in the world of attribute-based access control, you might be down to a single role that's going to be scoped to the types of actions you want a person to take, a developer, an operator, whatever the case may be, and all of the policies attached to it can be dynamic. Okay, so now let's look at an example of session tags, right? So here, I'm not going to use my little demo application, but I've got two example users, Richard and Mary. There again, I'm kind of using the same set of standardized tags. And again, the note there is the team, right? We've got Mary on Team A, and we've got Richard on Team B. They're going to log in through SAML into AWS in a way that you've been able to do for a long time. But what's kind of going under the hood, and it's a little bit hard to show, but we're going to do our best, is those attributes about team, department, and project are coming through from that SAML identity provider. And we're going to use those, and we're going to encode those in that short-term token that goes back to the user. And we're going to look at, actually through both the console and the CLI, how they can use those attributes to make decisions about who can connect to what instances using Session Manager. And I'm guessing you can forecast who's going to be able to connect to what. But let's look at it. Okay, so let's come back here, and we're going to go in. And so let's first go in, and we're going to log in as Mary. So I generally use, this is Shibboleth. That's the identity provider I use when I do all my demos. It's all very portable to any IDP that you would use. But we're going to log in as Mary. Okay, and you can see this is the standard, what's known as the role chooser page. And I'm going to drop into this EC2 operator role in a given account. Right, and so let's see. And so let's go in, now that I'm in there, let's look at what Mary's policy kind of looks like. So I'm switching back over to my administration view. I'll go into IAM. I'm going to go into the role, and I'm going to find that EC2 operator role that I just had Mary log into. And let's look at two things. One is just so you can see that there's no trickery. Like the role itself is not tagged, right? What I did before where I statically tagged the role, the tags are blank, right? The permissions, though, here look very similar to the sorts of policy that we were doing before. If I look, I'm allowed to do some basic describe types of calls, and I'm allowed to start and stop the instances that are tagged as I am in terms of project and team. And what we're going to show here, I'm allowed to start a session with Session Manager. Right? Okay, so let's go back and let's look at how this works for Mary. Right? So we'll flip back over into her view. That's definitely smaller. We're gonna go into SSM. Okay, we're in the right region. We're going to go into Session Manager. If you haven't used Session Manager before, really cool capability. So I've got 3 instances here. We'll look at the tags on those in a second, right? But trust me for now that the one that is test instance 1 is going to be tagged as Mary is, and you can see I'm kind of dropped right in. Now with Session Manager these days, you can drop into a named user. You can do all sorts of things. But essentially, I've connect to this running instance, right? And then so we'll drop out of that. And then as you'd expect, again, no grand drama. If I look at a different instance, that's tagged in a different way, I'm going to get, that's the first time ever the big red banner is nice and expected. I get the deny I expect, right? And so when you think about this, think about an auto-scaling group where instances are coming in and coming out. Here, through patterns like this, all of that is dynamic. Mary can still connect to exactly the instances that is appropriate for her role in the organization, and it's all dynamic even as things kind of come and go at cloud speed. So now we can also do the same thing, and we'll kind of show a little bit of it through the CLI here, right? But let me take a second, and I'm gonna dump out the SAML assertion. Now, if I thought that looking at JSON was painful, looking at SAML assertions would be like an order of magnitude worse, right? I would never wish that on anyone. And so it's all embedded in here, but essentially what I dug out were these, this is how it comes through in these SAML assertions. I just have standard sets of attributes, their principal tag, : tag name, right? And then here you can see that, I'm getting that project 3 and team B. And then if we look at our instance tags, this one may be a little bit tough as I've got this thing bumped up. Oh, so there we go. Sorry, I got to log in. So we're going to log in and see. I cannot. It's like impossible for me to talk and type at the same time. I have a one-track mind. All right, so let's log in as Richard as a federated CLI user. We're going to drop into that same role, that EC2 operator role that we did before. We're going to list our instances, right? Okay, did I choose the wrong role? I must have chosen the wrong role. Let's try that again. Richard Rowe. It's like never fun unless there's a little demo drama, right? So I'm going to go, did I choose the right role? Let's see, I got my little notes, EC2 operator. Let's go there. Okay, and let's list the instance role tags. Of course, okay. Man, you practice these things, and you got to have a little. So at least I hope you can obviously tell that I'm not mailing this in. We're really doing it live. All right, and 3, list instance role tags. Okay, so I'm not going to bother troubleshooting. I'm not sure where I'm going wrong here. Apparently I haven't had enough coffee for this morning, right? But the punchline was, right, that obviously Richard could move on and could SSH into the instances that were applicable for them. So let's even though I'm not, let's connect team B. Okay, so I don't know why my tags aren't coming back, right? But the actual net effects, right? I was able to here I connected to the instance that Mary was unable to connect to before by connecting to Team B Project 3, which again matched Richard. And then if the demo gods have maybe returned back to my side, I get my expected fail, right? And I kind of did the inverse of what Mary did. Still not sure what's going on with my tags there. I'll debug that later, but I don't want to, you're not going to watch me do that on stage, right? So apologies for that little hiccup. Cool, so let's flip back. Before we move on, I'm going to do one other thing that'll be relevant for a demo we're going to do in a second. I'm going to get an instance, and I'm going to put it here under a little bit of stress. I'm just going to use a little CPU burner. It'll make sense in a bit why we're doing that, right? So let's flip back, and let's look at what's going on. Okay, so here again, these policies are there for use later, right? But so I had to attach a fairly minimal session manager policy to the instances that I was connecting to. I then use an attribute-based access control policy to essentially allow Mary and Richard to connect to the instances that are tagged in their same way, right? And on the so we can we're attaching that to our federated users. And then the only other change that's necessary to use these session tags is what's known as the trust policy of your federated role. You've got to add this one extra action in, tag session. And this is you as an IAM administrator saying you accept you're going to allow the upstream IDP to inject these tags. And you can, if you're going to make some decisions about them, you probably want to make sure they're there. And so you can put in extra conditions to make sure that those tags are in fact coming through. So now I didn't show you a lot about how to configure session tags, again, because there's some great articles on the security blog that'll show you how to go through this. All of the attributes that are being used here, this is just SAML. This is nothing like unique or specific to any one IDP, but we did have a number of nice IDP launch partners, AWS partners that are in this space that have kind of they've A, done the testing with their own platforms, and B, they've in most cases put together some documentation on their own sites about how to use this, right? And so check out that more for how to get going with session tags. Cool. So the next thing I want to look at, or the last thing I want to look at in this kind of out-of-the-box portion of things is better least privilege through what I call security invariants, right? Again, things that you just know to be true. And so let's take an example of, in these days, most customers are going to have lots of AWS accounts. They're going to have lots of resources and roles and things in those accounts. There are also, I think I heard earlier today, there's now 22 AWS regions, right? There's a lot of regions out there. But most of you have a fairly clear understanding of what regions you wish to operate in. Now, you could go in and you could use requested region context keys to put restrictions on all of those principals and all of those accounts to make sure folks are only using the regions you expect. Or you can use one simple guardrail policy that you attach to your organization that just says these are the regions that I allow folks to use. And again, we're back to operating in that intersection model where we're using a guardrail overlaying on the various grants that operate in the accounts to achieve the outcome we're after. And in this case, essentially, what I'm using is an SEP. Now, this is a deny SEP. If you don't want your entire AWS environment to stop on a dime, it needs to be used in conjunction with an allow, right? But it essentially just says that for anybody in my entire organization, other than the services that are naturally global, like DNS and IAM and organizations, I want to make sure that all my principals are only calling into these regions that I expect, right? One policy, one place, and it's a security invariant. It will always be true because this is a guardrail style policy. Okay, now there's lots more invariants. I think we've got a fairly good sample library that are up there for you to choose from today. I don't want to spend the time to go through a ton of them because, again, they're in the docs. But I think you're going to find a lot of things that folks have been thirsty for a long time, right? How I lock down root credentials, how I make things that a central team deploys to all these various accounts immutable, and so forth. So there's lots of other invariants. Now, kind of same as before, especially with these, with many types of guardrails, but particular SCPs, these are big levers, right? These are levers that done incorrectly, can have massive impact and change in your environment. So my 2 words of wisdom are, 1, don't be scared of them. They are very powerful. They allow you to very cleanly rationalize about your environment, but do test them. Do roll them out slowly. Do roll them out with care. Right? Cool. So now let's flip over to part 2, right? So if part 1 was all about the out-of-the-box, like these are just things that AWS gives you, and in the pursuit of least privilege, let's talk about a little bit of builder magic, right? And so under the hood of everything we've seen thus far, there are a lot of awesome primitives, right? These Lego blocks. And, if you're willing to roll up the sleeves a little bit, if you're willing to stitch together some of these Lego blocks, you can really create some magical stuff. I have 2 kids at home, Izzy and Levi. I asked them to put together some fun Lego cars I could take a picture of for the slide here. And they came up with something radically different than what I had asked them to do that I thought was way cooler in the end. And that's, I think, also the spirit of what you, the builders in identity and security, are able to do, right? It takes a little bit. It's just not out-of-the-box stuff, but the collective creativity of all of you all is clearly more than what AWS provides you out of the box. And so, I won't soapbox about it too much more, but don't be scared of rolling up the sleeves and doing a little builder magic. So let's quickly look at, again, some of the things that we're going to use extensively in this section. You're probably all familiar with the notion of assuming a role. Not that many people understand that when you assume a role, you can pass in at runtime a policy. Now that policy is, again, one of those guardrails. It does intersection logic, right? And it essentially, the permissions of the token that are issued back are the intersection between what the role naturally had access to and what you've scoped it down. Now, this is absolutely the pattern for doing very dynamic permissioning in AWS. Like, you can't really do, or you should not do IAM mutating like attach policy, detach policy sorts of operations. This is the way to safely do dynamic permissions in AWS, right? Now, it's not that, some folks might use it to scope down their own privileges as they're like assuming roles on their own, but where these policies really shine are what are known as custom broker sorts of scenarios, right? Now, this also goes by token broker, token vending machine. There are a couple different names for it, but the pattern is basically the same in any way, right? This application, this broker that you build, it is responsible for authenticating and authorizing the user however you want. It then goes into its own data stores, whatever that may be, and determines the sorts of entitlements that you want the user to have. It assesses anything that we know about the user's device, about the situation in the cloud. Like, we can essentially query any sorts of sources we want. And then if optionally, you can generate then in code that scoping policy. And then the compute of the broker does the assume role call on behalf of the user, right? So I'm building that scope down policy in a trusted place. The user isn't providing it, the broker's providing it. And then when I issue back the token, again, what the resulting permissions are the intersection between the two. So now, where is this relevant, right? So I think we showed earlier how we can do some pretty unique and dynamic policy management around attribute-based access control. But I promised up front the notion of time, right? I'd argue to you that the problem that still has is why should, if that instance Mary is connecting to is like the crown jewels instance, why should she always be able to connect to it? Like, she should really only be able to break the glass when there's a problem, when something's going on. And if we want to layer in that notion of time, we've got to do a little bit of building, right? And so in this case, we're going to see how we could look to improve upon the example we did before and make it so not only is Mary able to connect to the right instances, but only at the right time when the situation really presents itself. So let's take a look. Okay, so we're going to go back and we're going to go to our user portal once again. Come back here, right? And so the first thing I'm going to do is log in. Now, again, I integrated this little application with my same Shibboleth identity provider through the magic of single sign-on, right? Mary didn't get prompted for her credentials again. So I'm going to do what would be obviously terrible to do in practice, but it's good to kind of demonstrate things here. I'm going to look at the underlying ID token that Cognito provided to this application, right? And so this is a JSON web token, right? This is a credential, so you definitely wouldn't do this normally, right? But so I'm going to go in, and I'm going to just go into this nice little decoder. We'll bump up the font size there a little bit. I'm going to drop that token in. I'm going to look for, so what I have done here is I embedded, again, this information came from my directory, went through the SAML assertion, went through Cognito, and I've populated in this token this little custom claim, right? And so here, again, because I'm building, I get to write the rules. And my rules for authorization say that I'm going to specify the accounts, that my convention is going to be account-operator team, right? And you can see here that I've given Mary permissions to these two accounts, and she's the operator for team A, right? And I'm going to make rationalizations about those are the instances that she's allowed to connect to, okay? So let's go in there, and we're going to go in, and so we'll list. Let's flip back here. Okay, that's one. So now let's go in, and hopefully my scripts here will be back to good working order. Right, so what I did here is, again, listing the instances. You can kind of see, same as I've been doing before, that they're tagged in the way that kind of matches Mary, right? So actually, let me flip in and let me do this. Let me get into Mary major. Okay, and so I'm going to here choose this count 0, this read-only role, and so just so you don't think there's any trickery, let's pull up and let's go. Let's show my instances. Okay, so here now I'm actually in the right role. So I've got here. You can see that this is my EC2 operators for this instance is clearly tagged in the way that I expect, right? But I'm going to grab that. And there are going to be no tricks, right? And so I am going to drop in, and I'm going to try to connect to this instance as is, right? And you can see that Mary does not persistently, even though it's tagged the right way, Mary does not persistently have access necessary. We'll flip back over to our little user portal here, and we're going to go into this demo, right? And what we can see here is, it happened all behind the scenes, but essentially the custom broker here went out and queried using the information from that token and got all the list of instances that Mary was pre-authorized for. And then it did something interesting. It looked and said, well, out of those, which ones are healthy at this moment? And I chose, that's why I jacked up the CPU on that one just to create a little, something that was different, right? But I've actually here in this case had an instance that is in fact alarming, right? Something's wrong with it. And I'm not able to drop in and connect to any of the other ones. But this one's obviously got a problem with it. So I'll go in, Mary hits that link, and she's issued a token, right? Again, not something you'd want to normally put on the screen, but if you're welcome to try to photo reconstitute this token, if you really want. It'll promise it won't get you into anything interesting. But I'll go back to the same window I was before. I'll drop that token in, so it's now my valid credential. I've been given this little command here. I'll drop that in. And now the instance that I couldn't connect to before, I can now connect to, right? I've layered in the notion of context. I've layered in the notion of time to further narrow down what Mary was able to do. Cool. All right, so let's drop back and let's take a look at what kind of happened there. So again, I started with my token application, right? This is just kind of the front end that helps me demo these things. And Mary has gotten it, the way the story goes, she's gotten an alert. She's gotten some notification that there was a problem, and she's showing up to kind of break the glass, right? I logged in with my corporate identity, again, kind of plumbed through into the application using Cognito, and I return that custom token, or the cup token, the Cognito user pool token, back to the application. And that is what the part that allowed me to make authorization decisions in the application about what Mary was authorized for. Now that app connected to a break glass API. Now if you are an infrastructure type, if you're a security type and you've never written your own API, write down Python Chalice framework, right? Like it is like I was terrified the first time I tried to write an API. It makes it so easy for you to get started, and you will find that it is not nearly as unapproachable as you might think. But at any rate, this API has two simple methods. The first is list my instances, right? And this is where we fed in those groups that Mary was authorized for. And the back end of the API goes and uses the EC2 describe calls in the various accounts to get the list of instances. It then starts asking questions about who's unhealthy, right? Now, I did a very simplistic example using CPU utilization. That might be fatal errors in a log. It could be whatever sort of criteria. Because you're in Builder Magic, you can essentially write those as you wish. So now Mary gets the list back, and now she says, "Hey, that's the one that's broken. That's what I want to connect to." And the application helps her call the second API endpoint, which is get token. And so that thing does two things. First, it kind of buzzed in my pocket, but I got a little notification on the phone. Hey, Mary's breaking the glass. And you can configure that to be whatever sorts of notifications you might want. And then, just as we saw in that custom broker model, the backend API actually does the assume role call on the user's behalf, generating that scope down policy. So the token that goes back is only valid for 15 minutes and is only valid for that one exact instance, right? Like literally the exact instance is the only thing that she can connect to. And then I used the CLI through Systems Manager to kind of drop in and go, right? So, I promised last year, I showed something very similar last year, and I promised that I would write a blog post, which is a promise that I did not live up to very well. So this year, we're not going to go through it line by line. If I scared you there for a second, all of this code will be in SlideShare. It'll be much better for you to get there. This is not going to be some ready-to-go thing, but you'll be able to pull out the kind of the core snippets and piece together something, or have some inspiration for how something of this nature might be assembled, right? So now let's look at a second sort of example where, again, we can use some of this builder magic to really improve the things that we've done thus far. So we talked earlier about how this attribute-based access control can really narrow down the sorts of privileges that a user has in a given account. But generally, in most organizations, there's another class of users. Sometimes they're called the cloud team. Sometimes they're called the cloud center of excellence. These are the folks within an organization whose job it is to look after the AWS estate for an organization. And a lot of times, they have some really powerful privilege to a lot of that estate, right? And I think that we can use the sort of notion of time to really improve upon that. So let's look at how we might do that. We're going to use the same pattern we just saw before. Essentially, we're going to use the programmability of the cloud to make a just-in-time decision instead of a persistent decision, but in a way that, and this is the important part, in a way that doesn't disrupt that person's job. It's their job to look after in a very powerful way across the organization. We just want to do it in a dynamic way instead of a persistent way. We're going to change out those static permissions for some notion that, again, because we're the builders, we get to define this notion of what a pre-authorization might look like. We're going to ask them, just as Mary did in the last example, to express some need and intent, right? I need to get into this this account now. We're going to then go through whatever rules we want to evaluate to figure out if that's appropriate, what sorts of approvals might be needed, whether they're automatic or dynamic. A thing I love to point out here is, especially if we're talking about sensitive roles across accounts, maybe one is okay, one is to be expected. If we find Mary asking for 10 tokens at the same time, that's probably a pretty bad indication of something going on, right? But this evaluate, because you're building, you can make it whatever you want. And then ultimately, at the end, after we're satisfied, we temporarily grant these permissions, right? Things that auto-expire, things that auto-reclaim out. Cool. So let's look at how we can apply this pattern to powerful roles in AWS. Okay. So when we logged in as Mary before, right? We noticed that she had this set of roles available to her, right? Now, there's no super user roles here. These would probably be the roles that Mary would do her experimentation, her building around in. But her role in the organization is a very powerful user, right? She's a privileged admin. But we can contrast that list, right? So let's look instead. Let's open a new browser window so I can clear out the authentication. So let's look at what the opposite example might be, right? So if I log in, so this is the way it's very traditionally done, right? So I might log in, and I've got all sorts of very privileged access, right? I'm a super user across all these accounts. I can, this is my job. I can drop in. I can do them as I wish. But that's not necessarily exactly what I want. So let's go back. We'll pull this 4D user portal again. I'm going to log in. I'm going to log in as Mary. Okay, and in the same way that I did before, again, I'm going to do my cardinal sin a second time. I'm going to take this ID token. I'm going to go back to the same decoder before, right? And we'll bump that up so folks can see it, hopefully. All right, so this was the custom attribute I used before. I just did something similar down here, right? In this case, I defined that Mary is a privileged AWS admin. It's coming through the same path. It's coming through a group from my directory. I could have done this more granular. I could have said she is a privileged admin in these accounts. It's up to me as the builder to define what my rules are. But at the end of the day, I defined that she was a privileged admin, right? Which means when she flips over here, right, and she goes and she might want to go and request temporary privileged access, right? And so I'm going to say that this is the account that I want to drop into at this time. Behind the scenes, we'll walk through it in a second, right? But we created the scenario by which she's now authorized to do that in the backend directory. I here just hit that link that I used a second ago. And now magically, I've got that super user role in my list. I drop in, I do my thing. We'll flip over and look at what was done. But trust me that 2 minutes after I did that, or Mary did that, that access was purged back out. If she went to that same page, she would no longer see that role, right? So we didn't measurably add any real friction to Mary's experience. So let's look at how we did that. All right, so same, going to be very similar to what we did before, right? We started with the same portal. Something was broken. A team member called. Hey, there's something I need you to look at in this account. I used Cognito to plumb through. I used, again, an attribute of my own making to make my authorization decisions about which accounts and which roles Mary was allowed to connect to. I did another API, right? This one was the Bump Me Up API. I tried to be a little cheeky with the name. Here, again, first thing I need to do is list the accounts that I'm authorized to connect to. I use the organizations API to list the accounts and the structure that are there. And now Mary says, hey, I want to go and do account X, right? Same as before. The second API that it helps her call is the access account. Now here, the first thing is, again, I didn't really show it because you would probably have done this with whatever ticketing system or step functions. There'd be a million permutations. But you can go through any sort of approval workflow you want. That could be automated. It could be manual. It could be two-person rule. Essentially, the possibilities are endless, right? But you're going to go through the approval workflow. We're going to do the same sorts of notifications we did before. And in this case, instead of issuing an AWS credential back, what essentially the backend did was it changed the group memberships in the backend directory, right? Whether that's using LDAP calls, whether it's using APIs for cloud programmable directories, whatever it might have been. Then Mary goes through and she's now got that extra entitlement in her AWS environment. She goes through the SAML IDP initiated login flow as usual, and she gets into the account. And then the magic is the permission was automatically reclaimed. The backend just dropped a simple message in a durable and reliable SQS queue, delayed the message for 120 seconds, which gives Mary plenty of time to log in. But then, right afterwards, just reverses that action, backs it right back out. Okay, so again, key snippets for later inspiration. It'll all be on SlideShare. I absolutely do not profess to be like the world's best programmer, but I'm dangerous enough that it should give you some inspiration. let's just do some quick parting thoughts, right? So I always say access management is a journey. Least privilege is a journey. But each and every step that you can take towards driving towards least privilege, whether that's dynamic policies, whether that's ABAC, whether it's custom brokers, those are wins for you and your organization, right? And so just be better every day when it comes to permissions. And my other takeaway is that, there's a lot of out-of-the-box stuff that AWS gives you that helps you in that pursuit, but don't be afraid. Don't be afraid of a little builder magic when you really want to create something that's truly your own. So with that, thank you very much. I really welcome and would appreciate your feedback. This session this year was almost entirely based on your feedback last year, so please keep it coming, and I'll stick around for questions, and I hope you have a great rest of the show. Thank you.